Welcome to the Deep Dive. This is where we take source material you're curious about, dig in, and pull out the key insights, the kind of stuff that gives you those aha moments.
Yeah, basically giving you the distilled knowledge without you having to wade through everything.
Exactly. And today, we've got a really interesting one. Listeners sent in this framework dealing with C, I, and E. That's coherence, information density, and energy.
All tangled up in something called the emergent time equation.
Right. And our mission really is to try and figure out what C, I, and E actually mean in this context, because it seems they're all defined by each other. It's recursive.
Very recursive. And that leads to some pretty wild implications, especially this idea of T0 for a photon. We definitely need to unpack that one.
Absolutely. So we know you want to grasp this stuff quickly but properly, avoid getting bogged down. That's the goal here.
Okay, so first things first. Trying to pin down a standalone definition for C or I or E here, it's tricky.
Because they're interconnected.
Totally. Their meaning really comes from how they relate to each other within this framework, this emergent time idea.
Okay, so what's the core equation then, the one that ties them together?
The main one is C key I and C, where T is the emergent time.
TT is the emergent time.
Got it. So the meaning of C, I, and E comes from their job in this equation.
Precisely. It creates what the source calls a self-consistent field. You understand one piece by seeing how it interacts with the others to produce T, the time.
Like ingredients in a recipe.
Yeah, that's a good way to put it. The flour's role depends on the eggs and the sugar, you know.
Okay, let's take them one by one then, as best we can. Coherence. C. What's the gist?
Coherency is basically the degree of order, how consistent and organized the relationships are within a system over time. Think of it as a scale from 0 to 1.
Zero being
Total chaos, like molecules bouncing randomly in a hot gas. Perfect order. The classic example is a crystal lattice, right? Everything perfectly aligned and repeating. Okay, crystal high C, turbulent gas low C. Makes sense. And its role in the time equation.
Well, look at the equation. T, squared for C, times IV. C is in the numerator. So higher coherence, more order.
Leads to more T, more experience time.
That's the idea. Coherence is like the structure needed for time to emerge properly from energy and information.
And it's not just one simple thing, is it? The source mentioned different ways to quantify it.
Right, which is fascinating. In quantum systems, you might look at the density matrix that captures the probabilities of different states, giving a sense of order. Classically, maybe correlation length, how far patterns persist.
Or synchronization in biology.
Yeah.
Like neurons firing together.
Exactly, or even geometrically, thinking about symmetries and constraints holding the system together. It's quite flexible.
Okay, C is the order factor. Now, information density, I. It sounds straightforward, but the source stressed it's not just data.
Yeah, that's crucial. Isn't just how much raw information, like bits, is crammed into a space. It's about meaningful, distinguishable connections or interactions.
Meaningful connections, so complexity. Interaction.
Think about a dense rock versus, say, a nebula. The rock has tons of atoms, but they're pretty static. The nebula might have fewer particles per cubic meter, but they're interacting, forming structures, processing information in a way.
So the nebula could have higher I, potentially.
Potentially, yes. The framework suggests systems tend to evolve from low I, few static connections, towards higher I, many dynamic connections.
And mathematically, how do they represent this meaningful aspect?
Couple of ways mentioned. A density, or S, is meaningful entropy, not just randomness, but complex, information-rich arrangements. Or idensity, frac HV, like meaningful states H per effective volume V.
Okay, and this leads to that wild idea that a few entangled quantum bits could have higher I than a huge inert object.
Exactly. It's about the richness of the connections, the complexity, not just the bulk.
Wow, okay. And its role in time, like C.
Yep. Look at the equation again. Square frac times IU. I is also in the numerator. So higher information density.
More experience time. Okay. C and I increase T.
Right. Now for energy, E.
Which we usually think of as, you know, the capacity to do work or something. But here
it's defined a bit differently, and this is where that recursion really bites. E is defined as the rate of change of information density over some reference time.
Wait, the rate of change of I. So weigh E, frac dI dt rad.
Exactly. Energy is how fast the meaningful information structure is changing or evolving.
So E depends on I and T, but T depends on E and I.
C. Recursive. It's all feeding back into itself. Energy is the system's capacity for change, specifically change in its information structure.
Okay. And how does E affect T in the main equation? It's in the denominator.
Right. TT is downstairs, so all else being equal, more energy in the system.
Leads to less experienced time, T?
According to this equation, yes. Higher energy, faster change in information perhaps, but a smaller resulting T value. It's an inverse relationship within that square root.
Okay. C, I, E, all defined together, affecting T wild. Now, you mentioned rearranging the equation.
Yeah, algebraically, it's simple. If T delta SRT times IE, then 2 delta 2 times IT.
So you can solve for E easily. E, far C times IE.
Right, or for I, 1 of far C times ET2, and for C.
And for C, E,
Oh,
CD, frac T times E down.
Exactly. These show the algebraic relationships. But, and this is the key point the source makes.
It's not just algebra.
No. The meaning comes from the whole self-consistent picture. The values have to work algebraically, sure, but they also have to match the fundamental definitions of C as order, I as meaningful connections, and E as the rate of change of I. It all has to hang together.
It's a whole system, not just interchangeable variable.
You got it. It's a web of meaning defined by these relationships.
Okay, which brings us to the photon, the T0 thing. This sounds like it breaks physics.
Huh. Well, it definitely bends our intuition. So, standard relativity tells us a photon, moving at light speed, experiences zero proper time. Its clock doesn't tick, basically.
Right, from its own perspective, if it had one.
So if we plug t as 0 into the emergent time equation, $0 times 0 times E.
Which means the stuff inside the square root has to be 0. So frasiagi times EOD.
Mathematically, yes. Or DO dollars times frat EE.
Okay, but hold on. A photon has energy, right?
Right.
Planck's constant times frequency. E isn't 0.
Correct. E is non-zero.
And it carries information, its polarization, its momentum, so I shouldn't be 0 either.
Right. It has a quantum state which represents meaningful information. I is non-zero.
And it's a wave, often described as perfectly coherent. So C should be high, maybe even close to 1. Definitely not 0.
That's correct. C is high.
So how can C dollar times frat E equal 0 if C, I, and E are all non-zero? That doesn't compute.
This is the crux. It implies a very specific balance or ratio between these non-zero quantities. For the photon, the combination frat E when multiplied by its high C must approach 0. It's not about any single term being 0, but about their interplay resulting in T0.
A specific balance. But then there's this other idea in the source. Timeless nothingness.
Yes, good point.
That's described as when E0, I0, and C is 0. Like literally nothing exists. No potential, no structure, no information, total absence.
Correct. That's absolute non-existence within this framework.
So how is a photon with its T0 different from that? If T0, doesn't that mean it doesn't exist in time? How could it be anything?
That's the critical distinction the framework makes. It's subtle but vital. Timeless nothingness is the absence of all three. E0, I0, C0. A photon has non-zero E, I, and C.
Okay.
Its T0 isn't because those properties are absent, but because their specific ratio results in zero emergent time for the photon itself. It exists, it has properties, but the emergent time calculated via the equation for its frame is 0.
So the framework differentiates between non-existence, all 0, and existing systems that just happen to have 0 emergent time because of how their C, I, and E balance out.
Exactly. It's a profound difference. The photon exists timeless, nothingness doesn't.
Wow, okay, that is subtle. So what does T0 mean for the photon then? What are the implications?
Well, think about it from the photon's frame. If T0, no time passes, that means no internal change. And its entire journey from emission to absorption.
It's instantaneous.
C for the photon.
Instantaneous. Even if from our perspective it crossed billions of light years. For the photon, emission and absorption happened at the same time, 0 time elapsed.
That's incredibly weird to think about. A journey across the universe taking no time at all for the traveler.
It is. And consider this. How do we define time intervals, simultaneity, distance? We use light signals, light clocks.
Right. We bounce photons around.
Exactly. So photons, these things that arguably exist outside emergent time according to this framework.
Are the very things we use to measure and define time within our emergent reality?
Precisely. They are the relational messengers. They establish the space-time relationships that give rise to our experience of time, even though they don't experience it themselves. Which loops right back to that recursive, self-consistent idea again. We're using timeless entities to build our concept of time.
You got it. It really highlights the interconnected, almost bootstrap nature of reality proposed here.
Okay, my head is officially spinning now, but in a good way. So let's try and recap the big takeaways for everyone listening.
Go for it.
All right. First, C, I, and E, coherence, information density, energy, they aren't really definable in isolation here. Their meaning comes from how they work together in the emergent time equation, PAC times AE. It's a self-consistent system.
Recursive definitions are key.
Second, that crazy TE0 for a photon isn't because it lacks C, I, or E, it has all three. It's because their specific ratio, their balance, makes T calculate to 0 for the photon itself.
And crucially, that's completely different from timeless nothingness, where C, I, and E are all truly zero.
Right. Existence with zero emergent time is possible in this framework. And third, photons, these T-Dial entities, are somehow fundamental to our construction and measurement of time.
Yeah, it's this ability to offer these kinds of fresh, maybe counterintuitive perspectives on really fundamental things like time and light that makes this framework so thought-provoking. It really challenges how we usually think.
Absolutely. Definitely gives you a wow moment or several.
Yeah.
So for you listening, we really encourage you to mull over these ideas. What does it really mean for time to emerge? What are the deeper implications of systems like photons existing outside of time as we know it?
Lots to chew on there.
For sure. Thanks for diving deep with us today.